Hey guys, I'm going to share with you how to actually perform this simulation. So you're going to click on the link that's provided to you. It's embedded in your classwork. If you're remote, if you're in person, then we're doing it for you here because we do not have a computer. So just as the directions state, you're going to click play game button, then click intro. So play game and then click intro. Okay, because we're only creating a simple circuit. Okay, that's what we know thus far. You will need a path, power source, and a load. Create your own unique circuit. So we need a path. Let's start with that. What am I going to use as a path? You can pause me if you're playing this in person or even remote. What am I going to use as a path? Okay, so yes, a path is a wire, so I know I'm going to need that. Now the next thing that I need is a power source. What am I going to use as a power source for my circuit? Pause me, pause, and then play it back after you answer. Okay, so the power source, I hope you all answered this, was a battery. Perfect. And then we need a load. So what are we going to utilize as a load here? What are we going to, a dog? That's interesting, a hand. For a load, we are going to use a bulb because we want something to carry over the electrons and we want to see the electrons actually working. Now we can create our own circuit. Okay, so based on the images that we've seen, I'm going to show you one that I created here. So this is one that I created. This is very simple. As you can see, I used two wires, one connected here, one connected there, connected to the load. I use a voltmeter to determine the voltage of my power source, okay, or of my circuit in general. So this is what you can do. You are going to connect. First, this is very important, right? We need that. We need to connect the path to the source. And then we connect the path to the load, all right? Everything here stays the way it is, but I don't see my load lighting up. Obviously, there's an issue. This is an open circuit, okay? An open circuit, based on your notes, is what? What is an open circuit? You can pause me. You can answer this as class. Okay, welcome back. So because it's open, no electrons are going to flow back from the power source into the load. Okay, it needs both. Right here is, remember, there are two ends to a battery. There is a positive and a negative. The positive has less electrons, the negative has more electrons. Well, we need it to create a current where it's continuously moving. Right now, it just stopped. Okay, so because of that, we need another wire. And we see that there's something happening. It's like reduced to 1% as normal. That's really interesting. So I wonder what the issue is here because my load is still not lighting, but something's happening here. Okay, there's something going on. So let's disconnect this. Let me see. You can refresh this, and there's a lot of other items that you can do, right? Because I know when I connected it here, my thing actually lit up. So maybe I connected something that was not okay. I like to use the voltmeter because I like to see what's happening. I like my battery because I need my battery. I need my wires. Yeah. Oh, no. Okay, that's cool. So you can see me fix this, right? So I see one has a negative. This is still this is a wire still. And then where's my load? Yeah, it's still lighting up. And then I'm going to create my voltage. My voltage is 8.67 volts. So that's cool. But how can I get that to light up? I can move this guy. Yeah, do that. Yeah, why don't you cut that out? There you go. So I need to have something connected here. I need to have something connected here, and now it's lit, right? And I wanted you to see that mistake because that's what some of y'all may do. It may connect to a certain spot, but it needs to have a current flow because right now, previously, like this represents the light bulb lit, but if you cut it and see, you need to connect it to a portion that is circled and it has the circles here for you. If I connected it to the same portion, my load is just getting shocked because there's just like electrons constantly flowing through my power source. So my load is not getting that at all. It's just going from wire to power source to wire to power source. But if I cut one of this, I can get wire to filament, right? Because we learned about the filament, the other conductor, and then wire into the actual load, and then we have it. Okay. So let's see our voltage. Our voltage is now 9 volts. And that looks really smooth and easy. So you see the pathways, the positive side is like getting those electrons, the negative side is pushing out those electrons to create a more stable system. All right, guys, thank you for doing your best and have a great class day.